Okay, let's go on now to the second way to model what we have, and this is the mean reference model. By the way, I have to say here that the means model is not something that is totally useless because it tells us statistically provides the answer if these coefficients are different than 0. We can still use it, but we should use it by using the contrast matrix that we haven't talked about yet. Anyway, let's go to the mean reference model. Now the way that we write the equation for the expression level, this is our response variable, the dependent variable, and these are the independent variables B0 and B1. Again, we have two explanatory variables here, B0 and B1. It's this one. So B0 is a constant factor, does not have any level next to that, and B1 is together with the x value here, and x is 0 for individuals that are in condition 1, for example healthy, and x is 1 if individual is in condition 2, for example sick. So with this way, if we have a healthy individual, then this will be 0, so this term will be 0, and therefore the expression value for the healthy individuals will be B0. So the model predicts that for the healthy individuals the expression value must be around B0. So B0 is here, is the mean value of the healthy individuals. Now for the sick individuals, this x will get the value of 1, and therefore for the sick individuals it will be that the expression value, it will be B0 plus B1 multiplied by 1 plus B1. So this level here, where the sick individuals, it will be B0 plus B1. And it will be the mean value of the sick individuals. Now this way is interesting for us and it's very helpful for us because this difference now from this level to this level is exactly the B0 plus B1 minus B0, which is B1. So if we estimate this value now, the B1, and if this value is statistically different than 0, then the healthy individuals are different than the sick individuals regarding the expression level. Statistically different. I say that again, since B1 directly represents the difference between the sick and the healthy, because this level is B0 plus B1 and this level is B0, the difference between them is B0 plus B1 minus B0 equals to B1, and B1 is this parameter here. Therefore, this parameter directly represents the difference between the sick and the healthy individuals. If the value of this parameter is statistically different than 0, then it means that the expression level for the sick individuals is statistically different than the expression level of the healthy individuals. Okay, so let's try to go back to R and see how to do that. Again, we have the healthy individuals, the sick individuals, we have the expression vector, and we have the condition labels. So again, it's healthy, 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 and sick. And the difference now is, we'll just copy that here. So this will be the mean reference model. The difference is that here we will not put a 0. So we try just to explain the expression as a function of the condition. Okay, I run this. So I remind you here that this is the means model that we saw in the previous video. We will not apply this now, but the model in this video is the mean reference model represented by this line. Now, if you want to remember it, the difference between these two, is since there is a 0 here, it's like the basic level is the level 0. So, for example, here in the means model, this is the reference, our reference, and we try to estimate whether this B1 and this B2 are statistically different than the reference level, which is a 0. Here in the mean reference model, one of the two conditions, the condition with the label 0 here, is a reference level. And for us, the condition with the label 0 is the healthy individuals. So we want to see whether the sick individuals are statistically different than the reference level, which are the healthy individuals. Okay, so summary my model, it's this one, and we have here the following. Now the intercept, which is this B0 factor, B0 parameter, the common for both sick and healthy individuals, is 3.7, and it represents the mean value of the reference level, which is the healthy. So it's 3.7, and the condition sick, which is non the reference level, compared to that is 13.17 units higher. So the mean expression for the condition sick is 3.7 plus 13.175. So the mean expression for these individuals is a 3.7, which is the B0, plus the B1, which is 13.17. And more importantly, this 13.175, which is this difference between here and here, it is statistically different than 0 because the p-value is 0.00804. So we reject the null hypothesis that this is 0, and we say that for this data, the expression level of the sick is statistically different than the expression level of the healthy individuals. Okay, so this is the mean reference model.